Hi everyone. We're Frightings. Well, we want to generate music through a random input. This is a member of our team. Next. So the purpose of this project is to generate 5-track music through a random noise. We used drums, piano, guitar, bass, and strings as our 5 tracks. That's it.
So one baseline model we are looking at is the MuseGAN model proposed by Hao Wandong team. Model is trained using GAN, and the main architecture inside the model is CNN network. And one interesting design is the random input Z, which have been pre-processed to be able to capture the track dependency and time dependency. But this model also have its limitations since it only uses the CNN network. It can only capture time dependency within bars, but not able to capture between bars. This means it will lose the consistency between bars and let alone the long-term consistency. In light of this limitation, we want to revise our model by adding LSTM modules to help us capture long-term dependency between bars. Besides, harmony among all tracks also is not satisfying, but this is not our main focus. From the figure, we can see, as we discussed before, we add LSTM layers to connect tracks CNN or the CNN layers built both in generator and discriminator in order to capture the long-term dependency and generate more harmonious music piece. The whole process is that we input the random data into generator and let it pass through trans layers to get the fake data and feed both fake data and the true data into discriminator. Then backward, to train the discriminator to let it distinguish differences between the fake and true data, and train the generator to learn to generate the fake data closer to the real data. So in the table, you can see the parameters we use to construct our generator and discriminator. And you can see we have 7 transconf layers in the generator and also 7 CNN layers in the discriminator. As for the GAN loss function, to reduce the instability of the min-max games, we use the objective function for generator and discriminator, which implement the feature matching. It uses part of the generated output in the mid layer of discriminator into the loss function to help stabilize the training process. And moreover, it can also help control how much the current bar sounds like the previous bar, which also improve the harmony of all through the bars.
So for the training, we use very similar training data set. The only difference in the data set with the MuseGAN data set is the time step. In MuseGAN, the time step is 48, but in our training data is 96. So the target we generate through our model is 8 bars times 96 time steps times 84 pages and 5 tracks. So here, let me display some results. The first one. So here's the second best result we get. So every 10 seconds, there's a pause. And the next 25 times 8 bars is the input is depend on the previous output. So that gives some little harmony in our music, which is better than MuseScan. But a lot of samples we generated are still very unharmonized with a lot of noise. And here's the reference we have. And thank you for the presentation.